I have enough memory then. Don't let it drop on the floor. That's the YouTube account.
Observe by Jamie. I'm gonna check it out.
Recording?
Yeah.
Good idea. They let you put it like on a microphone, so you can record their voice, but you can't record the person. I mean, he's been doing it for ages. They haven't said anything.
Oh, he actually put it off, you know.
That's exciting. Now I know. I started it.
I don't think we'll want like more 3G in it. So put that on.
No, damn it, yes. Text me next time if I break. Text me, if I break. I'll have a look at it, but I don't think it's going to be much helpful anyway.
I think it'll be muffled as well, but I think the speech will be like, because she's fast. Put my headphones on. Huh? Is it on today? What time?
Straight after.
Oh, what? Straight after?
Straight after finance. What I'm thinking, like, if I should like go or not.
Yeah, because I thought I was going to go library. Yeah, that's right. My Wi-Fi's not going to work and I can't even watch it. The video's good. Have you checked them? Are they good, like the videos? My Wi-Fi's not working, I don't know why.
Oh, you can hear them, you can hear them.
Can you see the board though?
Go like look it up on your laptop.
I hear him knocking on the window going. Like not being in the house.
He's gonna look at me funny, you know. He's gonna be like, it's not even mine. Same Steve's like, why are you recording this? Huh? I know, so there's no point doing it now.
Looking at you like.
I lie, like, moving, but it's not even mine. I didn't even know. I woke up What is it? Yeah, I'm hearing about it. What is it? Apparently you buy stuff and you give it or something like that. So do you get something? Where is it? Where is it? I'll wrap all the gifts up. Where is it? So what, you buy a gift, you give it and you get a gift? It's on Tuesday. Is that what you do? What do you do? What do you do?
Okay, we stopped. We stopped on Tuesday working out what the derivative of ax squared plus bx plus c is from first principles. Basically, we just plugged in the definition, and we worked out that it was this expression there. Just as a reminder, basically, what we're trying to do is work out effectively if this represented a traveling object at varying speed, then we want to know what the speed of that object is at any point on this graph effectively. And the way to do that is by effectively approximating it by a straight line. So a straight line, we know, basically represents the speed of an object traveling on a straight line. And by defining it that way, we can effectively shrink this straight line down to this point that we're interested in, and that will then give us the instantaneous speed at that point, which is effectively represented by these delta y and delta x, which is defined to be f of x plus delta x minus f of x all over delta x, and we're taking the limit of x, delta x tending to 0. So we're making this slope, this chord, smaller and smaller and smaller, and have it vanish at that point, basically. And that gives us the derivative, or the speed at that point. So this is the more formal definition. So if this expression here, which is what we've got here, so it's effectively representing this chord, instead of that chord, if that expression tends to a finite limit, so it doesn't tend to infinity or anything, or plus or minus infinity, then we say f, the function that defines the vertical graph, is differentiable at that point. And the derivative is equal to the limit. And basically there are various ways of writing this. I'll tend to use f dash because it's fairly straightforward, and it lends itself later on when we look at derivatives of derivatives. We can just keep adding dashes to the actual things. So that's basically sort of the formal definition. So here we're now going to go through some of the rules that we've got for differentiation. And for those who've done it before, that's probably just a recap. However, I believe that you might not have actually had proofs of those necessarily. So I will prove quite a few of them. I'll ignore some because it's not really helpful. Basically, don't worry about the proofs in the sense that I'm not going to ask you to reproduce them. But basically, I'm just trying to put them on to make you see that those proofs aren't really that difficult. They're just manipulating symbols, basically. So here we've got the first rule, the multiply rule. So if you've got a function f of x, so anything like this, okay, that is differentiable. So at every single point on here, we can actually work out the limit. And we've got some sort of constant that we want to multiply this thing with. Then we can define a new function, g, which is basically just c times f of x. So basically every point on that graph of f, I just multiply by some constant c. So I might double it or